All right, everybody, we're going to talk today about how to solve a systems of equation using a matrix. There are 4 different ways to solve a system of equations, and some we've talked about already. Substitution, elimination, graphing, and then the 4th method is by the use of a matrix. So we have a system of equations that I've set up for us. 2x plus 1y equals 1, and 3x plus 2y is equal to -2. The first step in solving a system of equations is to take these numbers and convert it into a matrix. So a matrix is made up of something called a row and something called a column. In the top row, so horizontally, we'll be listing all of the coefficients that belong in our first equation. So our first equation has 2x plus 1y, and then this line is similar to an equal to sign, equals our constant, which is 1. So our first row is made up of all of the coefficients from our first equation. And on our second row, we'll have all of the coefficients from our second equation. So 3x plus 2y equals -2. Now we're going to be using our calculators today, and hopefully you have those programs that I put into your calculator. So we're going to start by simply putting the initial matrix into our calculator. So in your calculator, use the yellow second button and this x-1 button that has the matrix above it, and go over to edit. The first thing that we're going to have to do is tell our calculator what the size or the order of our matrix is. So the size or order of the matrix is just a list of rows and columns that our matrix possesses. So how many rows are in our matrix? We had 2 equations, so there's 2 rows. And then how many columns? We had 3 columns. So we would say our matrix has an order or size of 2 by 3. So if your calculator doesn't have it already, just hit 2 and enter and 3 and enter, and it will either shrink or expand your matrix to make it as big as the one that we have on the paper. So the next thing we need to do is go in and type in the coefficients from our matrix. So the first one is a 2, and hit enter, and you'll notice that your cursor starts going across. 1 and enter, 1 and enter, 3, 2, and -2. So hopefully you have all of your coefficients in there, and we're ready to get out of this window, so hit second mode or second quit. Now we're going to be working with this matrice through a program called ROWOPS. So here's your program button, and go to the one called ROWOPS and hit enter. And hopefully it'll bring up that matrix that you just typed in. If it didn't, if your numbers don't match the numbers that are on your paper, we need to go back and we need to edit that matrix from the start. We don't want to keep continuing to work with a problem that has the wrong number. So if these numbers don't match the ones on your paper, let's go back and we're going to have to edit it before we start using this ROWOPS program. Okay. So this is our matrix, and our overall goal is to end with a matrix that looks like 1, 0, and then a number on the other side of an equal sign, and 0, 1, and a number on the other side of your equal sign. This is called Gauss-Jordan elimination. And what it does, it makes the solutions to the system of equations easily read from the matrice. So if you see, similar to what we have above, this thing says 1x plus 0y is equal to a number, or x equals a number. And this bottom row says 0x plus 1y equals a number, or y is equal to this number. Now if our matrix or our system of equations was a little bigger, we would have a little more work to do, but it would still take on this similar characteristics of our overall goal. So this is what we hope to accomplish by using the following 3 matrice algebra operations. So the 3 things that we're allowed to do to a matrix is to interchange the rows. So the three things that we're allowed to do to a matrix. The first is interchange rows. So what that means is we could take row number 1, move it down here, let it become row number 2, take row number 2, move it up to the top, and let it become row number 1. All right, I don't know if that's going to help us that often, but maybe we can find a use for it. The second thing that we're allowed to do is multiply every entry in a row by a non-zero constant. Okay, so if we wanted to, we could take all of row number 2 and multiply it with a 1 or a 4 or a 6 or whatever number we needed to do to reach our overall goal. And the third thing we're allowed to do is add a multiple of one row to another row. So these are the three things that we're allowed to do with matrix operations. So let's get back to our matrix at hand. The system of equations we wanted to solve had the form 2, 1, 1, 3, 2, negative 2. Now to start working with these three matrix operations, we need to know where we're headed. So what we're doing is we're heading to this overall goal of ones in the diagonals and zeros everywhere else. When we start working with our matrix, we're going to be working in columns. So look at this first column. What we need to do is turn this upper left entry into a 1 and everything else into zeros. So we're trying to turn this entry into a 1. Here are the things you're allowed to do. You're allowed to interchange rows. Okay, that's not going to help us. You're allowed to multiply every entry in a row by a non-zero constant. You'll notice if I multiply 2 by 1/2, it results in a 1. 2 times 1/2 would result in a 1. So what I'm going to do is multiply that top row by the number 1/2. Now, like I said, we're going to be working in our calculator, so bring back that matrix that we just saw and hit enter, and you'll see that it has those commands. We're going to swap rows, we can multiply, we can do this thing called pivot, and we'll talk about pivot in just a second. But what we'll be doing in our calculator is operation number 2 to multiply. So anytime we want to get a 1, we'll be using to multiply. What row did we need to do our multiplication in? Row 1. So we're going to choose option number 2 to multiply. We'll be multiplying row 1 and hit enter by what number? 1/2. And the trick to turn a number into a 1 is always going to be multiplied by the reciprocal. So we wanted to turn this 2 into a 1. What did we do? We multiplied by the reciprocal of 2, which is 1/2. So that'll be our trick every single time we want to get a 1. So if we do that and we hit enter in our matrix, in our calculator, we'll see that our new matrix looks like 1, 1/2, 1/2, 3, 2, and negative 2. So we created a 1 in this upper left corner. We're working in columns. The next thing we'll do is turn this 3 into a 0. So here are the things you can do. You can interchange rows. That's not going to help us out. You can multiply every entry in a row by a non-zero constant. So is there anything I can multiply with 3 except 0 and get 0? No. So the only other option I have is number 3. Add a multiple of one row to another row. Is there something that I could multiply with positive 1 and add to 3 to get 0? There sure is. And the trick to getting 0 is always to multiply by the opposite sign. So for ones, we'll be multiplying by opposite fractions. For zeros, we'll be multiplying by opposite signs. So we're going to do -3 times this row that has the 1 in it, which was row 1. And we're going to add it to row 2. Add it to this 3 down here, the row we want to change, to create a new row 2. If you look in your calculator, you'll notice that that option is not there to add one row or add a multiple of one row to another row. So we have to swap rows, to multiply, and finally to pivot. This operation, getting zeros, is covered in your calculator under to pivot. The thing about pivoting is you have to tell your calculator what entry you would like to leave as a 1, because it's going to turn everything else into a 0. So in this column, what entry did we want to leave as a 1? This one that's up here in the in the left upper corner, which happens to be in row 1, column 1. So we're going to tell our calculator that we want to do option number 3 to pivot in row 1, column 1. So our new matrix looks like 1, 1/2, 1/2, 0, 1/2, and -7/2. So we're halfway to our goal of a Gauss-Jordan elimination matrix. We've got 1s and 0s in the first column. Our next goal is to turn this second column into 1s and 0s. Now every time you start a column, the first thing that you need to do is obtain a 1. So if we need 1s in the diagonal, it means that this 1/2 now has to be turned into a 1. Is there anything that we can multiply with 1/2 to make it turn into a 1? Yes, a 2. So like I said, the trick for turning something into a 1 is always just to multiply by the reciprocal. So the reciprocal, or the flip fraction, of 1/2 is 2. So 2 times row 2 to create a new row 2. In your calculator, this is under to multiply. And we'll do that every time we want to get a 1. We'll use this function to multiply. So hit enter. We're going to do option number 2 to multiply. We'll be multiplying row 2 by 2. So multiply which row? Hit 2 and enter. By what number? 2 and enter. And our new matrix looks like 1, 1/2, and 1/2. And then our second row looks like 0, 1, and -7. So if we stop for just a second and look at our matrix, right now it says 1x plus 1/2 y is equal to 1/2. And down here on the bottom row it says y is equal to -7. So we're almost there. The next thing that we need to do is take this 1/2 and turn it into a 0. So here are the 3 things that you're allowed to do. We're allowed to interchange the rows, which we've done far too much work at this point to interchange the rows. The second thing you're allowed to do is to multiply each entry in a row by the same non-zero constant, but there's nothing I can multiply with 1/2 that would turn it into a 0 other than 0. So my last choice is add a non-zero multiple of one row to another row. Is there something I could multiply with 1 and add it to 1/2 to get 0? Yes, there is. The trick is, and the trick will always be to get a 0, opposite sign of the number you want to change times that row with the 1 in it plus the row you wanted to change to create a new row you wanted to change. And like I said, anytime you're getting zeros in your calculator, this is under the to pivot function. And to pivot means what would you like to remain as a 1 in this column, because everything else I'm going to turn into zeros. So the 1 that we want to remain is in row 2, column 2. So we'll be pivoting around row 2, column 2. So in your calculator, we're going to choose option number 3 to pivot around row 2, column 2. Row 2, column 2. So our new matrix looks like 1, 0, 4, 0, 1, negative 7. Okay, so now we can read directly from this matrix the answers to our question. What is the ordered pair that makes both of these equations true at the same time? We have x is equal to 4 and y is equal to negative 7. So the solution to this system of equations is the ordered pair 4, negative 7.